So compound inequalities are basically two inequalities in one. It is kind of like in English, if you think of a compound word, like sunflower or skateboard or schoolhouse. It's two words made up into one. That's basically what a compound inequality is. Compound inequalities are basically two inequalities that are combined into one statement, and kind of like a compound sentence. He went to the store and he bought some cake. You can use the word and or the word or with compound inequalities. And indicates that both of the statements of the compound sentence are true at the same time. The overlapping region is what's called the intersection. So for example, if I say to you, I'm thinking of a number, and my number is x, and it has to be greater than 5, and it has to be less than 10. What this is saying is that both have to occur simultaneously. You have to be a number that's bigger than 5, but at the same time less than 10. If you were to graph that, if this was 5 and this was 10, x was greater than 5 would go in that direction. X is less than 10 would go in this direction. And so you have what we call an overlapping area, which is called the intersection. So all those numbers in between are what make the inequality true. Now, one of the things that they do is that for and inequalities, what they do is they write them with a symbol, if you look here, with the x in between. If you know that x has to be greater than or equal to -5, and at the same time it has to be less than or equal to 5, then you know that you're somewhere in between the two, and then you would write your and inequalities with the letter in between. Think of it this way. If you read it from middle to left, it would say x is greater than or equal to -5. And if you went from left to right, it would say x is less than or equal to 5. So both of these inequalities have been combined into one with an and inequality. The solution set is basically this conjunction with the intersection shaded. Similarly, an or inequality is also a compound sentence, but the intersecting or the combined regions, they're not intersecting. They don't intersect. It's called a union. So an intersection is the middle part of an and. The union is what they both provide together visually. It's the answers, but they are not overlapping because it's not the same answer. For example, if I said x has to be less than -2 or x has to be greater than 6, what I'm saying is that you can either be less than -2 or greater than 6. And you'll understand if you think about it rationally that you can't be both. You can't be less than -2 and at the same time greater than 6. It doesn't make sense. So that is an or inequality. Now, just like regular inequalities, compound inequalities require solving. And the solving of the inequalities are basically going to create two separate inequalities. Let's look at this example. A movie ticket for a child younger than 13 costs $5.95. A movie ticket for an adult that's 13 to 64 costs $8.95 per ticket. And senior citizens 65 and older costs $5.95. Write and graph an inequality that describes the ages of the people whose tickets cost $5.95. So let's look to see who costs $5.95. A child younger than 3 and 65 and older. So if we think rationally, let's say the ages, let's call ages, we will use the letter A. And so if you look at the two inequalities, we have A is less than 13, because you can either be younger than 13, and the other situation is that you can be greater than or equal to 65. And because you can't rationally be less than 13 and greater than 65, it's an or. You can either be less than 13 or greater than or equal to 65. Now to graph this, we're going to go to the number line and we get 13. It's an open circle because it doesn't have extra ink. So see, there's no extra ink under here, so that's open circle is less than. And this one is greater than or equal to, so we're going to go to 65, and we're going to close circle in there, and it's greater than, which means it shades to the right. All right. You notice that the graphs do not intersect, so the compound inequality is union. Remember, intersecting means that it goes together. This is a union. Next one. All right, let's look at the next question. Solve each compound inequality in graph. So now you see the compound inequality, it's a little strange looking. There's not just the letter X in between. If you were to cover up one side, you would notice that it was a regular inequality. And if you covered up the other side, it looks like it's a regular inequality. So basically what you're going to do is you're going to treat it like you would a normal inequality. The only difference is that whatever you do to the middle, you do to all. This is the side of the inequality. Now it's got 3 sides as opposed to just 2. To solve, you're going to minus 6, but you do it to all sides. That gives you -9. You rewrite your symbol. Rewrite the 3x, 6 goes away, is less than 6. Next step, divide by 3 to all of it. Remember, you only flip the symbol if you're dividing by a negative, and he's not a negative. He's a negative, but it's being divided by 3, so you do not flip the symbol. In this case, you get -3 is less than or equal to x, which is less than 2. And in order to graph this one, you are going to go to the number line. Begin with -3. It's a closed circle because it's or equal to. Then go to 2. It's an open circle. And because it's an and inequality, because it's in between, you're going to know that you're going to shade in between. And the solution would be, if you remember the set builder notation, values of x such that, and then you just write the inequality answer as it is. Alrighty. This is also another and you can tell because there's one in between. There's no word or. You're going to notice that the other ones are going to have the word or. Add 10 to all sides. -9 plus 10 is 1. We write less than. X less than 5. This is an and inequality. It's an intersection because there's that variable in between. You go to 1, it's an open circle. You go to 5, it's an open circle. And if it's less than 5 but greater than 1, it's an intersection that looks like that. Set builder notation, values of x such that, and then you write down the actual inequality. Okay. Notice this one is an or inequality, and I can tell it's an or inequality because it's got the word or. You're going to solve them separately, separate inequalities. Add 1. You know that 2a has to be greater than 14. Divide by 2. A is greater than 7. That's the first one. Or subtract 11. You get -6a is greater than or equal to -12. Now you're going to divide by -6. So you have to remember to flip the symbol. A, now this symbol is going to flip, and -12 divided by -6 is +2. So you are either less than or equal to 2 or greater than, open circle because it's not or equal to, 7. And you would say the values of A such that A is less than or equal to 2 or A is greater than 7. Standard form is always to put the smaller number, the one with the smaller value first. But if you didn't do that, I would not necessarily take points off at all. So I don't want you to stress about that. Another or. Now we're going to -2, and you're going to get r is less than 10. Or subtract 5. r is greater than 14. Both of them are open circles because it does not have an or equal to. Go to 10, open circle, less than 10. And now 14, you're going to have to extend this number line. 11, 12, 13, 14. An open circle on 14, and it's greater than. And again, set builder notation, values of r such that r is less than 10 or r is greater than 14. Alrighty. And last couple of questions before you are working on your independent practice. Looking at this, we know that it's an or because it goes outward. You're either that way or this. This is an or. If you are in between, it's an and. So this one here, we know is going to be an or. We look at this one, and it's an open circle, as is this. So both of those symbols are going to not have the equal to. So this one is the -2. We know that the x value has to be less than -2. This one is at 5. That means x has to be greater than 5. It's an or, so you would say x is less than -2 or x is greater than 5. This one is an and. Start with the -2. You know that if you're going that way, that's greater, so you would say x is greater than or equal to -2. And if you're looking at the 5, if you're going that way, it's less than, so you would say x is less than, it doesn't have the or equal to, 5. And to combine them, you put the x in between, you put the bigger number on the right, you put the smaller on the left. Remember to continue looking to see where it's pointing at. It's pointing to the -2, and here it's pointing to the x. And you get -2 is less than or equal to, because it's a closed circle, x, which is less than 5. All right, so that is the lesson. You will go ahead and complete the independent practice, graph the solution sets. This is an or. Make sure that you're looking here as well and complete these. The answers will be posted up on Canvas after your due date. So please complete this so that then you can go ahead and work on your math space.